Let's talk about something that sounds like it's been pulled right out of a sci-fi movie: electronic skin. Seriously, we're on the verge of a future where our gadgets aren't just something we hold, but something that becomes a seamless, soft part of our own bodies. That really brings up a pretty fundamental question. Just think about it for a second. Our bodies, they're these amazing, soft, flexible, self-healing machines. But the tech we use every single day, our phones, our medical gear, it's all hard, rigid, and kind of clumsy. Why is there such a massive gap between our biology and our technology? I mean, on one hand, you've got what we have now: bulky hospital monitors with all their wires, smartphones that are basically glass and metal, and wearables that, well, you always know you're wearing them. But the dream, the vision we're chasing, is completely different. It's a sleek, skin-like patch that moves and stretches right along with you. So, how do we get there? Well, to close that gap, scientists needed to find a material that could actually mimic our own body. And that brings us to the first part of our story: the hunt for a perfect, body-friendly substance. You can think of it as a kind of smart jello.
And it turns out the answer was something called a hydrogel. So what is that? At its heart, a hydrogel is just a network of polymer chains that holds a ton of water. And honestly, the best way to picture it is exactly like Jell-O or a gummy bear. It's squishy, it's flexible, and because it's so similar to our own biological tissue, it's incredibly biocompatible. It's pretty much the perfect starting point for something that's going to sit on your skin. Now, not all hydrogels are made the same. You can make them from synthetic stuff, which is awesome when you need them to be really strong and precisely tuned, or you can make them from natural materials, which gives you amazing biocompatibility. It's not about which one is better, it's all about finding the right recipe and balancing those trade-offs for whatever you need the e-skin to do. Okay, so we've got this perfect material, it's soft, it's body-friendly, it seems like we've solved it, right? Well, not quite. There was one massive, glaring, deal-breaking problem that almost stopped this entire field right in its tracks. Yeah. A normal hydrogel has an electrical conductivity of basically 0. It's an insulator. And if you're trying to build electronic skin, being unable to conduct electricity is, a bit of a showstopper. It's like trying to build a race car with square wheels. It's just not going to work. So what do you do? If your base material won't conduct electricity, you've got to mix in some stuff that will. And this is where scientists basically became master chefs, coming up with a special recipe to turn our smart Jell-O into a genuinely smart sensor.
And the process is actually pretty simple, almost like baking a cake. First, you start with your hydrogel base. That's our Jell-O. Then you mix in some special conductive ingredients, which are technically called fillers. Once everything is mixed together, you just shape that new material into your flexible sensor.
And these magic ingredients, these fillers, they're the absolute key to this whole thing. They're what create little pathways for electricity to zip through that soft, watery network, giving the hydrogel its electronic superpowers. And it turns out researchers have 3 main types of these ingredients they like to work with. So there are 3 main categories of these conductive fillers. First up, you have carbon-based materials like graphene and carbon nanotubes, and these are famous for being incredibly conductive. Second, you've got liquid metals, which are amazing because they can stretch and even heal themselves. And third, there are conductive polymers, which are just fantastic for connecting directly with biological systems. What's so cool about this is that there's no single best ingredient. It's all about picking the right tool for the right job. You need a super sensitive sensor? Go with carbon materials for their top-tier conductivity. Need something durable that can bend and twist and maybe even heal itself? Liquid metals are your best bet. And if you need the most seamless, body-friendly connection possible, you'll want to use conductive polymers. Okay, so we've got our material, we've got our recipe, we've successfully turned our smart Jell-O into a working electronic device. So the big question is, what can this thing actually do? This is where it gets really, really cool. For starters, it can be a next-level ECG electrode. Think about those cold, rigid, sticky patches they use in hospitals. Now, imagine replacing them with this soft hydrogel that just sticks to your skin perfectly. You could wear it for days, comfortably, getting nonstop data without even being in a hospital. That's a total game changer for spotting tricky heart problems. And look at this, the proof is right here. The signal quality you get from one of these hydrogel electrodes is almost identical to the bulky gold standard electrodes used in hospitals today. It can clearly pick up all the critical parts of the heartbeat, the P, Q, R, and T waves. This makes it an incredibly powerful tool for monitoring health in the real world without getting in the way of your life. But it's not just about listening to your body's signals. E-skins can also track its every move. You stick a patch on a joint, like your finger or your knee, and as you move, the hydrogel stretches. That stretch changes its electrical resistance, which turns your physical motion into a data signal. Just think what that could mean for physical therapy, or for an athlete trying to perfect their technique. And then things get even wilder. In one amazing demo, researchers actually made a wearable keypad out of these hydrogel sensors, and then they used it to play a computer game, controlling the character just by pressing on this soft skin-like interface. I mean, how cool is that? But as awesome as gaming on your own arm sounds, there's still a bit of a gap between these lab demos and everyday reality. Okay, so let's take a quick breath. It's easy to get carried away by all this cool stuff, but we need a quick reality check. The results are amazing, for sure. But there are still some pretty big hurdles to clear before you can just go buy an e-skin patch. The challenges right now are really practical ones. For instance, since hydrogels are mostly water, they can dry out. How do you make sure they work for weeks, not just a few hours in a controlled lab? Then there's the money question. How do you manufacture these things cheaply and at a huge scale and make sure every single one is perfect? And, of course, the biggest one, they need to be proven to be completely safe over the long term. But the final vision here, it's absolutely revolutionary. It goes way beyond just sensing things. The real goal is to create what are called theranostic platforms. It's a fancy word, but it just means a system that can not only diagnose a problem, but then actively treat it. Imagine it automatically releasing medicine through your skin the second it detects an issue. It's a complete, closed-loop system for personalized medicine. And that brings us to one last really big question to think about. As this technology gets better and better, as it moves from being a device we wear to something that feels like it's truly part of our own body, it just completely blurs the line between human and machine. It opens up these incredible possibilities, for sure, but it also forces us to ask ourselves, when our technology becomes a part of us, where do we draw the line?